structural engineering challenge, or the challenge for the day, are going to be two things, and this is what we will send out to you. And so I'm going to talk about it kind of briefly. You will have it, then you can do this activity over the next week. And then we will meet again, and you can present some of the ideas that you had, and show me some of the things that worked or didn't work. And we can discuss those and talk about, from an engineering perspective, why some things in paper, why something was failing or working or not failing. And so the idea is going to be that there are two different types of structures. One of them is going to be a bridge or a lateral structure, where you're going to try to get the longest span that you can possibly do to support a given load. The other is going to be a vertical structure like a crane. So you can think of design A being designing the bridge, and design B working with a crane in order to pick up a piece of the bridge to put it into place. In order to do this challenge, there's going to be a series of materials that I'm hoping are, kind of around the house, that you've got these. And if you can't, improvise. This isn't a set thing where you have to do it in an exact way, but ideally, if we have several different people that tried to do the same thing with the same materials, we can have more of a comparison. But have fun with it. Anything else would be fine. And so 20 sheets of office paper, paper clips, some straws. If you don't have straws, you can use something that's approximating a straw that you might have. Some string, that 12 feet would be ideal. Chopsticks. If you don't have chopsticks, you can use pencils, you can use whatever. Large 16-ounce cups. If you have different sizes, you can use the other sizes. And then if you want to use sand or rocks or anything that just fills, it could be a weight that fills the cups, or you could use it, to fill something else, or any way you want to use this material, but the volume of it should be about 3 of these cups full. Okay. And then scissors and so forth to cut things, a tape measure to measure the dimensions that you're going to do. Scotch tape is ideal. That's what I usually use, but if you have a glue gun and you want to use a glue gun, that's fine as well. And the idea is that I'm going to show you the challenges in a minute, but take pictures as you're doing this with your phone or whatever, so that you have kind of a record of, I tried this and it worked, I tried this, it didn't work, because that's really, the engineering process is really documenting things and reacting to that somewhat. And then eventually we get that we know what works and we develop all of the equations to make that work. But the preliminary work should be somewhat of an intuitive, try things, kind of learn by trial and error. So the idea, I broke this into 3 parts. The first is your initial thoughts of just thinking through those materials that I talked about. This is on your own. Just say, oh yeah, I think this would work good in tension or compression or bending, and how you might be able to combine some of those materials to make them work together. Then do the construction over the next week, take pictures along the way, and then we would meet later to discuss what you came up with and see what designs worked or didn't work. Have fun with it. And now let me show you the 2 different challenges and the details of that. Okay, that didn't work. Sorry about this, just a second. There we go. Okay, so the first one of these challenges, as I said, is trying to get the longest bridge possible. And so the inside, you can come up with some, or you need to come up with some supports using the material that you have. This bottom part could be a tabletop or the floor, and you're going to build it up and then have a span across. And at the center of it, where you're putting the load, there needs to be at least 7 inches from the bottom of whatever you're building down to the ground. At the ends, it needs to be at least 2 inches from the bottom of the structure to the ground. So this can taper or it can be straight, however you want to do it. You could build the entire thing 7 inches and higher, or you could build it 7 inches at the center and then a lower clearance at the ends. But the idea is using all of those materials that are allowed to get as long of a span between your supports, so from the inside to the inside of the support, as far as you can span to support a 1/2 pound weight. And if you have something that you can measure that 1/2 pound, that's great. If not, you can, as long as you're doing something consistent, that's fine. So, can of tuna fish or, something along those lines that you could put on there and see how far you can span with that given load. But ideally something about half a pound. Okay, that's challenge 1. Challenge 2, and you would pick one or the other of these. If you really want to go all out, you could do both of them, but I would expect, I'm hoping that some people would pick one, some people pick another. And the other one is that there's a base at the bottom that you need to come up with, somehow getting this to be 18 inches off of the ground. So from the ground up, 18 inches is going to be the bottom of your structure. And then something that weighs a quarter pound, so 0.25 pounds, up located at the top. And the idea is to see, the challenge is to see how far away from this support, from the center of the support, you can get it to stand up. Okay. And so you're building up and over. There is one thing that a lot of times, if you don't read it carefully, you miss, or maybe you just don't. It's a rule that's supposed to make it harder. So maybe some people would decide to skip that, but please don't. And that is that at the bottom, it needs to be just free. Like you can't tape this down to the ground or glue gun it to the ground or wedge it under something. Same with this bridge. At the ends, it needs to just be sitting on the ground or the tabletop, not taped down or rigidly attached to anything. Okay, so those are the 2 challenges. And as we said, that if you put your email into the chat, Steve will collect all of those at the end of this, and we will send out these rules on the challenge and the slides. And in the slides, as I mentioned, at the end of the slides are also some that I didn't take the time to show, but some different construction methods that are some YouTube videos from construction companies that personally I think are just some really cool visuals of how time-lapse photography of some different bridges being constructed to give you an idea of how some of these are done. And I think that is everything that I had prepared to present. I'm more than happy to answer some questions, and that could be about the challenges, about the slides, or about structural engineering or engineering in general. So I'm happy to answer anything that you might have.
So there have been some questions about the video being made available, and it is going to be on the Hopin2 platform, and I'll put in so that we're going to load that up it should be available tomorrow, and anyone who's interested, I put my email in the chat and they could email me for instructions how to use Hopin2, which is where the video will be. But I had a question, Scott. So a simple question to start off with. The weights that you said it had to hold are a half pound, and is it a half pound and quarter pound?
Yeah.
What is that like? Could you give me like an everyday object that's
yeah? So that's I should have done this before I came over here. I could try to find it. I know that a can of tuna fish, I believe, is the half pound. Like a cat food or tuna fish is approximately a half pound. So pound is 16 ounces weight. So we're talking 8 ounces and then 4 ounces for the 2 weights.
Yeah.
So if you have a packet of food and you see that on the side, it's like a solid thing and it says 4 ounces or 8 ounces, I believe, I'm trying to remember how much a quarter stick of butter is, but I think that might be getting close to the quarter pound. Of course, you don't want to be spending 5 hours working on this with butter slowly melting over your structure. So
yeah, the first thing that came to my head is obviously to put a cup of water, but that gets messy.
Which you're doing it at home. It's not my problem. So that's
yeah.
fine. No, but the other thing is that if you have a scale to weigh this, like you may or may not have it if you're doing it in this in classes. Maybe one of the science classrooms has an actual scale that can measure, half pound and quarter pound. But if you just get a cup that has some rocks in it, or just any object, and you put it on there, and you're close ballpark, close to a quarter pound, half pound, that's what I would like you to use. And if you can't find that, you can still do the challenge using some other weight that might not be exactly what I'm asking for, but still gives you the same experience.
All right, thanks. And let's see, could you go back to the first diagram? For
the diagram in the
first challenge, yeah.
Yep. And I think when we send this out, if you can give me like an hour before you send stuff out, Steve, I can go to my kitchen scale and just weigh out like, pens and pencils and get a sense of how many of them is a quarter pound versus half pound.
Yeah, we're not gonna get this done until tomorrow. I can't do it. It has to be Paula.
Yeah.
So the what is the distance from the left end to the right end?
That's what you're trying to maximize. So you're
Okay.
trying to figure out how far you can span this using any type of structure you want with the materials that are allowed. And so that might be something. And also, I want to clarify that I keep talking about bridges because that's what I do a lot of research in. I am not specifying that this needs to be a bridge. This is a structure that supports a half pound weight at the midway point, and it needs to be at least 1 inch wide. But you don't need to think of this as being something where you need to be driving something continuously across. It could have gaps in it and so forth. The challenge is to have something that's at least 1 inch wide at, that there is something that's 1 inch wide over the entire width, our entire length. But the main goal is just supporting this weight at the center and making these supports as far away as possible. And so if you get something that works that is, say, 12 inches long, that doesn't mean you're done. It means that maybe that was too conservative and maybe you can make it 18 inches. And what could you do to it using the same materials? Or maybe you didn't use all of your materials to make it 24 inches, 36 inches, and just keep trying to expand it and get as long of a span as you can possibly get. And the other way of doing it is not start small, but just start with a really, a design where you're trying to get as, a 36 inch if possible, or, 48 inch, and then you find out it's not working and work your way in once you figure out what's limiting your span and try to get something to work at the optimal longest span you can get.
Okay, so this is Lou.
Yeah.
I just want to make sure I understand this challenge. So looking at the view, basically you're trying to build something that can hold a half pound weight. Okay, and
Correct.
then so the point in the middle that shows kind of like a white space, is that something that means here has nothing? That's an empty slot.
Right. What it
Okay.
means is that under whatever you're supporting,
Yeah.
that support needs to be at least 7 inches off the ground.
Okay.
And at the ends, it needs to be at least 2 inches. You could
Okay.
make this entire thing 15 inches off the ground would be fine.
Okay.
Anything 7 inches or larger at the center. And then
Okay.
once you get beyond that weight, it needs to be at least 2 inches.
Okay. And the length is also, there's no restriction on length, like the length of the bridge. Okay.
There is no restriction because that's what you're trying to, the challenge is to see how big of a number you can get that to be.
Okay. So ideally is you want it as long as possible?
Yes, that's the
Okay.
challenge.
Okay.
And it could go thick up in the platform, huh?
You can make things as thick as you want it, but if you're making it really thick, you're using a lot of material. And if you're using a lot of material, you might not have enough material left to make it long. And so, there's a trade-off. And these two, the reason that I give these two numbers is that I guess I don't want to lead people into, oh, this is the way to do it or not do it. I've seen really successful designs with a lot of different ways of constructing this. But if you think of those different bridges that I was showing, there were some are arch bridges, and arch bridges tend to be high at the center and low at the bottom. Beam bridge tends to be, or beam or truss tends to be consistent all the way along, which would mean the entire thing needs to be 7 inches off the ground and higher for the thing to be supported, the weight to be supported. You might have something that's more like a suspension bridge where you're tying it off down here and then draping some cable, coming up higher. And so I'm not saying you need to use any of these types of bridges. I'm just saying that the reason that I'm allowing it to get more less clearance over here, but it needs a maximum clearance in the center, is that for if you were to think of this as a real bridge, let's say there's a waterway here that needs a boat coming through that needs to be this high. Okay, but off to the side of that, it's not the shipping channel, and maybe you don't need as much of a height restriction on it.
What is the material limits?
Material limits are, for both challenges are the same. And it's up here, which is, and once again, these will be when you don't need to write this down or anything like that. These will be sent out to you, these instructions. But it's basically 20 sheets of paper, bunch of paper clips, straws, string, chopsticks or pencils, like anything that's along those lines, some cups, and then any sand or rock. It could be pennies, anything like that to fill those cups, or to fill 3 of the cups, but you don't need to use it inside the cups. You could use it anywhere you want. And then the rest of it is just materials to tie things together, and a tape measure to measure your, oh, and actually I should have mentioned, tape measure. If you have the smaller tape measures, those one year whichever tape measures we bought happened to be almost exactly half a pound. So, you know, that might be exactly what you're supporting as well.
And is there constraints on the Scotch tape and glue?
I used to have those, and let's leave it open this time because I don't know how many people are doing this, and be creative. Like, you know, if you see loopholes in the rules, that's fine. That's if there's a loophole, that's a way of thinking outside the box and coming up with something.
Okay.
I will say that what I used to do is say that all the Scotch tape had to be at least 2-inch, you know, lengths. And then of course there's somebody that said, oh, well, I cut it in all these 2 inches and then I just taped them all together and I ended up with my 12-inch length that I originally wanted. So, you know, which was a good solution. So, yeah, and the glue gun, I mean, I don't want a bridge that's completely made out of glue, but you know, I'm not gonna restrict that. We'll see if people come up with things that aren't what I'm thinking of. That might actually could be a way of skirting the rules, or it could be a way of being really innovative and coming up with a really cool structure.
Great.
Can we see it in page number 4? Is that also part of the design?
Page 4.
Yeah.
Yeah, page 4 is the other challenge, which is this drawing.
Oh, okay. So you pick one.
Pick one or the other, or I mean, if somebody wants to do both, you can do both. But
sure.
my intention was that you would pick one or the other, because I think that the main reason that I gave both of these is I know that in some schools, people have already done something somewhat similar to the bridge. Maybe it's building a bridge and then putting as much load. I would say that have fun with this, and so don't do something you've already done. If you've already done it, move on and try a different challenge.
Okay, so this is not necessarily a bridge, right? Is it just a weight carrier?
Right. So this one is more like my concept or my idea on this is more like the crane that is used to construct a bridge. This would be the load hanging from a rope that we're picking up in order to swing it around and drop it down and put the bridge into place. If we're just lifting up, moving the bridge and putting the bridge into place in order to construct the bridge. So it still has to do with bridges, but this being more, I'm thinking of it as kind of a crane and some of the issues that come up in designing a crane and how we construct a bridge, whereas the other one is more in the final bridge, how we limit the length of a bridge.
Okay, so this is more like when you, in your presentation, refer at the end that how do you construct a bridge? Okay, put that material on. Okay.
Yeah, and using the exact same materials in order to meet this challenge. But since you're trying to get this to all stand up off of one post, it doesn't have to be one post. You know, keep this can be anything you want it to be, but you're measuring from the outside of whatever your support is to the weight, to wherever you're putting your weight. And so if you make this wider and wider and wider, you're actually limiting what your actual reach is of this crane thing.
Is there any constraint on the width of that platform?
Nope. So you can make everything, whatever, and that's what I was trying to say is I'm showing this as like a vertical member. It doesn't need to be a vertical member. Really, the only rule on this is that there's going to be some sort of support that you have on the ground or the table. There's going to be some weight up here, and however you get it to, you know, to make that, I did kind of a standard. This is what in my mind a crane looks like, but that does not need to be what you're building.
Great.
So, is there going to be an October 30th check-in? Is there going to be another webinar or something as session?
Yes, so I need to check. It is October. Yes, October 30th is the check-in. I don't think we've set the time yet.
Okay.
Yeah, the time is what time you're available, Scott.
Yeah, so. Yeah. Okay, so I I thought I was waiting on Paula to tell me, but if
Well,
this
probably,
time works for people, it'll probably be at this time, maybe earlier. I basically have any time, most of the day blocked off just to schedule
Okay.
around.
It's
this.
probably better to be after 4
After
o'clock
4?
because the kids have classes
Yep.
until like this time.
Yep. And so if that's the case, then after 4 works perfect for me. I just have, so the only thing I have that day that I can't schedule around is 2:30 to 3:30.
Okay.
And so after 4, or if there's somebody else that is doing this in their class and wants to do it during class time, I could do it twice during that day, or, I mean, Steve,
Sounds great.
you and I can talk about how to do it.
yeah. So we could tentatively say, I don't know, was 4:30? Is that a good time?
That works for me.
4 seems should be good. 4 actually will be
4
good.
o'clock? Okay, so we'll say,
Yeah.
we'll say 4 o'clock, and then we may have another in-school session that will be during the school day with the class.
Yeah.
If anybody wants, and like I said, I don't know who's, and we're still recording this. I don't know if you want me to keep recording. Or,
Yes, I
no,
think
so-
at this point, are there any other questions?
Yeah, for me, I just need to figure out that a platform should be, I'm assuming should be relatively straightforward, and just going to try to look at the recording again, so get familiar with the concept and the challenges for my daughter. Yeah.
And ideally, from my perspective, what I was hoping to have, and whether this works or not, depending on who's doing it, would be for everybody to put together like some photos, almost like a document of here's what we did, and the last part of the rules kind of state this. And as you're doing it, take pictures so that next week in that check-in, you can show me pictures of we tried this, but it didn't work, and we can talk about from engineering points of view or forces in the structure, why that might not have worked. Then you did this, and why did that work better? When you changed it to a
Sounds great. Yeah. Okay.
Great.
Okay.
All right. Well, I think you've answered the questions and made the activity and very clear. So I think we're good, Scott.
Okay. Well, I look forward to seeing what people come up with, and yeah, I hope you enjoy it. And I'll stop the recording now.